Right. This video is to show you what to do when you're asked to find a sum of a geometric series and they don't give you the number of terms. So what's happening here is n is unknown. We don't know what it is. We don't know. Usually would they have an s and a number after it to tell us how many numbers we're going to add up. We don't know that. So we're going to have to use our knowledge of sequences to figure out how to know how many numbers there are. So you know how to do sums, some of them, haha, and then you also know how to find terms. Well, we need to find term numbers. So we're going to use our formula for geometric terms, which is this one. All right, so we already know the last term. We can't put a number in here because we don't know what that number is. That's the number we don't have, but we do know its value is 6,144. We also know the first value, which is 3. What are we doing when we're going from number to number? It looks like we're multiplying by 2. 2 times 6, 12, 12 times 24. So the r is a 2. So the only thing we don't know is we don't know that piece. So we've got to figure out how to do this. So what we're going to do is we're going to first of all, we're going to divide everything by, we've got to get this by itself, and that's the tricky part. Okay, we're going to do 6,144 divided by 3. That's 2,048 equals 2 to what power? So what we're trying to figure out is 2 to what power gives us that amount. So how are you going to do that? So we're trying to figure out 2 to what power gives you 2,048. So 2 times 2 times 2 times 2 times 2, so many times are going to give you 2,048. Alright, so this one's kind of a tough one, but we're going to tackle this by thinking about making these equations kind of equivalent. So we're going to do this, and then we're going to try to do is figure out 2 to the what power gives you 2,048. So the easiest way to do this one, honestly, is you go to your graphing calculator. This is what I would do. Go to your graphing calculator, type in 2 raised to the x power. Okay. Then go to your table. So you hit second graph to the table and look down here until you see 2,048. There it is, 2,048. So 11, it's to the 11th power. So that's how I would kind of cheat through this a little bit. So now 2,048 is really to the 11th power. When we get further on in math and we talk about exponentials and logarithms, there'll be a much easier way to do this. But that's the way I would tackle this. So if these two things are equal, would it make sense that 11 equals n minus 1? If this is to the 11th, this is to the n minus 1, wouldn't it make sense that 11 is equal to n minus 1? So we're going to add 1 to both sides. So we now know we're summing up the first, these are 12 terms. Alright, so now we can do our formula. So 3 times 1 minus 2 to the 12th power, all divided by 1 minus 2. Which just makes that negative. Alright, so I just have to put in 3 times, get out of this. Use my mouse. 3 parentheses 1 minus 12. Excuse 2 caret 12. Divided by, basically that's negative 1. I don't know why I'm doing that. I know that. So the answer to this is 12,200 and let me go back. 12,285. 12,000. 285. And that's my answer.